Hello, hello. Last time I streamed, I added this parallax background to the game. Right. And these are defined the same way that we had this foreground working, right? So we can edit this polygon, and each one of these layers is just a different polygon, right? So it's being rendered the exact same way, just at different distances from the camera, right? In 3D. So we have this illusion of 3D. It actually is 3D. It's real 3D, right? Except that the geometry I'm rendering is flat in the Z direction. Yeah, you can actually see this. I draw this coordinate frame, right? And this blue axis is the depth. Yeah, so it's actually 3D, right? And there are some issues I want to look into. Like, it's really like finding this. We want to be able to move around these vertices, right? So we basically want to pick one of these vertices depending on the mouse position. And that is pretty wonky right now. For some reason, I thought it worked, but apparently not. So you can see this blue one is the vertex that I have selected, right? Or the one that is going to be grabbed if I click, right? And that should be the closest one to the mouse, which right now it really isn't, right? Like if I hover this vertex, this blue one gets highlighted. This one gets highlighted for some reason. And yeah, it seems off, right? It seems like it works pretty well in this foreground case, actually. It seems to be getting the right vertex. Let me try to add some more just to check. Yeah, this seems fine, but for some reason it fails back here, and that's really strange actually, because what I do is just project these vertices onto the screen, right? And I can compare it with the position of the mouse on the screen. Yeah. So I do the comparison in UV space, right? And the weird thing is that, like when I draw this outline and I draw these points, I do that in screen space. So it seems like the projection code is working because these are at the correct location. So I'm not really sure what could be wrong, but let's investigate. So if we're not in insert mode, that's the normal mode here. This is okay. So if I hold shift, right, I can subdivide this polygon. So I can select an edge and just click, and that adds a point in the middle here of those vertices. And this actually seems to be working correctly. So, oh yeah, this one is working fine, right? So there's something with this other mode. I don't have a name for. I guess I'll call it edit mode. So when we're not subdividing this polygon, we're editing it. And yeah, it's definitely wrong somehow. But how? So I got the other code correct. So let's see. This projected point, right? I made this helper function to project a 3D point in the world onto the screen in UV space. And I guess I could just try to draw that point, I guess. But the weird thing is that I already do that. I already do that because that's what we're seeing here. So the points seem to be at the right place. And I use the mouse UV. That should be fine also, right? But maybe we can draw this mouse UV actually. And I will draw this as well. So let's see what that looks like. Okay, those are wrong. Oh, right. Okay, this is the issue, actually. I need to calculate the depth, so the position along the z-axis of every single one of these polygons. And this is outdated, I think. I made a helper function for this. So we have this get parallax layer depth. Okay, that's a lot better. So I just send in the layer of the polygon, and that should work now. So I can just remove this. Okay, that's working now. Nice. However, now, when I actually pick up one of these vertices and start dragging, this position is also really off from my mouse cursor, and that's just because I basically didn't change the logic since I added this parallax scrolling, or this perspective camera, right? So I have to change that completely. So how do I do that right now? I have this like drag, what's it called, edit polygon, right? So when I actually click my mouse, we assign this edit polygon, and we have the edit vertex, which is the vertex index that we're dragging around inside of this polygon. So how are we calculating this new position? Right. Yeah, so this editor project screen to world, that's my old function that I was using when I had an orthographic projection. Because this doesn't make sense if you have 3D, right? Because I want to project some screen space point into the world, and that just isn't a thing, right? Because the mouse, like you just can't do that, because you have to add, you have to get the z-axis from somewhere, right? So what I want to do instead, I think, is I want to define a line in 3D space that's defined by this mouse position. So I'm basically shooting a ray out from the camera position into the world, right? And the direction is gonna depend on where my mouse is on the screen. And now, since I know the depth of the polygon that I'm editing, all I have to do is intersect that ray with a plane on the XY axis that's perpendicular or orthogonal, right, to the XY axis, this X and Y. And that intersection point should give me the place where I want this vertex to be. So let's try that. So I have this project world to screen, which is working now. So I basically do want the reverse of this, basically. But it's going to need one more parameter. So we'll have something like, I guess we'll call it project screen to world, or is that already? Okay, that's already. Okay, let's actually move this to the top of the file, kinda, at least here. So, okay, I still want this old one to be working for the like camera movement. It's still used for that. So when I right click, we still use that that function to calculate all of this. So let's call this project screen to world 2. Perfect. So we'll have some screen space position and we'll supply that as a UV. And we want some depth value. Yeah, let's call it depth. That's going to be between 0 and 1, right? Yeah. And this is going to give us a 3D point in space, right? So I guess first we have to reverse all of this basically. And that should be pretty simple. So let's see. We have the view projection matrix. So we want the inverse of this. I guess I could put it here, but also I can just invert it on the spot here for now. So yeah, I can move that later. But we need the inverse view projection matrix. Like that. And let's see, we need the normalized device coordinate position, like the NDC. And the X is going to be the UVX. And we scale it up, right, and move it. Yeah. Like that. And the Z will just set to the depth. Right. And now we want to... Wait, is that... I'm not sure if this is correct, actually. Hold on. Well, okay, actually, let's just not make a function like this, because what we really want is like, we want to create a ray in 3D space that's defined by some position on the screen. So we can do something like create view ray, maybe camera ray. Right, and what is a ray? So a ray is, we'll have to output two things here. Because a ray has some kind of origin, right? And it has a direction. So that's what we want to output. We could make a struct maybe that holds these two. Maybe later, sure. Okay, so we want to create a ray. Because I'm really unsure about this math right now, but let's try to... So there's not going to be depth anymore, because we'll just handle that here. So let's try to do this. Let's try to do this. Because we want to project 2 points into world space. One will be at the near plane of the camera, and one will be at the far plane of the camera. Right, and I don't really remember how to do that from the top of my head. But I think it's basically this. So I guess we'll have a near point and a far point, right? And let's see. I mean, yeah, we're gonna have to do this 2 times. Well, maybe not. This is a bit hacky, but so we'll have this. I think I have this matmul homogeneous. Yeah, so I don't have to do this at least. So the projected point is gonna be this, and we use the inverse, of course. So that's gonna be in world space now. So let's try to do that. Maybe we don't need these scopes actually. And the only difference now is gonna be that the far point is gonna be at 1.0 depth. And then the direction of the ray is just if we subtract the far from the near, right? So we're shooting the ray from the near point, or back 2, and we have to normalize that. Normalize. And the origin is just this near plane point. That's probably it, maybe. Let's see what happens. Right, so when we are editing a polygon, yeah. Let's see, okay, I still want this just because legacy. So we'll have the, let's call it the origin and direction. Do I have the camera? No. The editor has the camera. And the UV. Right, so this mouse position is in pixels. So do I have the resolution in here? Actually, does the editor know the resolution? Yeah, okay. I store that here. That's good. So I have the mouse UV. Well, actually, I already calculate this in the update tick function. So let's just steal this. And yeah, we can use the mouse post because we assign it here. Okay, sure. Like that. So now we have an array, and I actually already have a function to intersect a ray with a plane. Right. So I can just use that. And this should always return true. I guess we can assert that. So we know whether we hit. Let's assert that for now. Right, so we have the hit distance, origin, direction. Alright, and the plane. The plane. Let me think. Well, it's at least going to be orthogonal to the XY plane. So basically this. And the normal shouldn't really matter here. Except for... yeah, it shouldn't matter. Right. So what we also need... this code looks really messy. So what we also need is like the depth value, or the C value, of the polygon. And I have this function for that, right? So world get parallax layer depth, and we have the edit polygon layer, right? And I'm thinking, because I don't know if it should be positive or negative. I have to think about that a bit. So the way plane is defined, right, is that these first three is just the normal of the plane. And that's correct here, right? That's correct. However, this last one specifies the distance of the plane from the origin. So let's see if this depth, so I'm thinking it should be minus here, but let's try. Let's just see. So once we have a intersection, we know the hit distance, so we have to figure out like the hit position, right? Which is simple also. We just add the origin to the scaled direction of the hit distance. Like that. And oh, wait. Right, the wait, is this fine actually? Because okay, the vertex only has the x and y. Let's try that. Right, because this z is always going to be the depth of the polygon. I think that's fine. So we'll just extract the x and y from this position. Implicit declaration. Right. I have to include my intersection functions. Intersection? And assert. Alright. This is probably going to go horribly wrong. Yeah. Okay, so we don't hit the plane, which makes me think that if that is the case, then it's probably behind the camera, right? And I don't actually remember if I made this fail when the plane. Okay, let's try to make this 1 instead. Alright. Yeah, okay, as I expected, I have to flip the y coordinates. Oops. So in this function, so the y should be inverted. I think that's it. Okay, that's. So I guess maybe when I do that, I should add 1, maybe. Yeah. Okay, that's perfect. Now it's actually at the mouse. Feels good. Nice. However, something that doesn't feel good is that we're just going through every polygon and we're finding the closest vertex, right? That's simple. However, like right now I can just drag these vertices. I'm basically picking through the layer that's in front here, right? I think I would really like if this was like, if we check the collision basically, or check that, I guess, yeah, we just want to check that this vertex is occluded, and if it is, we just shouldn't grab it, because yeah, and that might introduce some problems, because I can imagine, like, what if you actually want to edit this layer? But for that, I think I want to be able to specify. I think I want the ability to basically hide layers up to a certain point. So if I want to edit these bottom vertices of this plane or this layer, I would just hide the ones in front somehow. I think that's a good solution. So yeah, I think I can try that. So for that, I guess when checking every polygon, I just all I have to do is project every triangle of this polygon into the screen space as well, and just intersect, check if the point is inside of the triangle, I guess. I think I already have that function somewhere as well. So right, let's see if I have that data. So when we're finding the closest point here, the closest vertex, right? And this is executed for each polygon, right? So I think before then, okay, as a first try, let's see here. Okay, so that's a bit because okay, let's see. If I open the game, there should be in the world like collision, debug draw, collision, triangle collider, debug draw. It's reversed. Right, so these are the ones I want to check collision against, right? So we have some triangulation algorithm that generates triangles from these meshes, and I should be able to use these to check with my mouse, right? I just check every single one of these triangles if the mouse is intersecting them, and if they do, then I just stop basically, and I find the closest vertex on the polygon that I actually hit. And the slight problem with this is that this triangle data, I only have this right now for this the closest layer, because I only needed it for like this gameplay collision, right, with my player. So now I'm actually gonna need it for all layers, and I wonder how I should make that happen. How should I make that happen? So let's see. So somewhere here in the world, we call this triangulate. function. Right, we do it every frame. Well, I mean, I could just do this in the editor. Like, I can just re-triangulate it, really. I guess since it's only needed for the editor as well, yeah, I can just do this every frame. I think that's fine, actually. So every frame for each polygon. Alright, so let's try to do that. So I go through every polygon in the world here. I have the polygon. And now I just have to call this triangulate function. Right. And I guess the other issue, maybe, is that this is private inside of the world translation unit. So let's just move that out into the header and expose it. And we also need this triangle structure. I guess that feels a pretty unnecessary, actually. I mean, this could just be a list of uints or whatever. Yeah, it feels pretty unnecessary to have that as a separate data type, actually. Right, so that's that. Now we can actually call this. Right. And I actually think that we essentially already do this somewhere. Because for this player collision, I think we do this. Like, we check if the point is inside of the triangle. So let's see if I can copy that code. Let's see if I can find it. Okay, so we create the planes in this. Okay, I guess this is fine, right? Yeah, so the easy way of determining if a point is inside of a triangle is just defining some planes for each edge and checking if the mouse is behind all of them. And that means that we are inside. There might be an easier way, like a simpler way mathematically, but let's do this still. And maybe I can create a helper function for this. So we want something like, yeah, okay, we can make like a generic one, right, in 2 dimensions. So we'll have something like intersect, is it really intersection? I guess it is. Intersect point triangle 2D. So we'll have the point, and we want the 3 vertices of the triangle. like that. And let's basically copy this code. So, right, we need the edges. Okay, sure. This feels really unnecessary. I mean, is there? I guess I could check. 2D check if point is inside the triangle. Yeah. Checking on which side of the half plane created by the edges the point is. So yeah, it's the same idea, right? But you can probably do it a bit faster. Right. So this sign. Okay, that's cool. Let's just steal this. And how was this used? Where the point and right. I would like to rename these arguments. So what we essentially have is the point. Oh, well, maybe. Okay, I think I see what this function is doing, right? Right. Right. That's a lot more efficient than what I was doing. Right. And we can steal this whole function. So 1. Be gone. I want tabs. Alright, I guess let's see if this works. So in the editor, we have a list of these triangles. And I guess... yeah, let's just go through every triangle. Triangle index. Triangle index. Like that. So we have the triangle, and we can retrieve the position of those vertices. Like this, vertex position. And that's a 2D, right? Actually here, I think we like use this polygon, yeah, this layer depth, right, a lot. So we can just do that here, right? Because if we have the polygon, that's all we need, right? So we can call that something like polygon depth, maybe. Right, so we don't have to call this all the time. Yeah, and we do it here as well. just use that depth here. Yeah, we still have to do it there. Right, so what we have... Yeah. Just get every vertex. And this is a 2D point. Okay, that's pretty annoying. Pretty annoying, but let's do this. So we have the 2D position of every vertex in this triangle, and then we need to project these onto the screen. Right. So we want to use the same function. And I guess we want to do it the exact same way. So we have something like a projected point 0. Or maybe projected vertex 0. Right. Let's just... We needed all of this before. Why did I put this? Let's do that here. Right. So I still need the camera. And right now, let's see. Yeah, that's just a V0x, V0y, and the depth. So now I have the screen space points of this triangle, and now I can use this intersect point triangle, right, 2D, right? And the position point I want to test is the mouse UV. And the vertices are these projected vertices. Is inside, wait, is mouse inside triangle? Sure. So, if the mouse is inside of the triangle, we should just not do an intersection testing on this polygon. I think that's fine. So let's do something like this. If we are intersecting the triangles, then we just continue. Right. Wait, no. If it's not, wait, hold on. So, right. As soon as we find an intersection on any of these triangles, then we know that we should continue, right? So this is true, this is false, continue. Right, I think this makes sense. Yes. And this is wrong. V1, V2. Why does it take so long to close my game? Okay. Okay, that is actually working first try. That's working first try. Or is it? It seems to be... It seems to be a bit off, maybe? It's a bit off. At this point, it's not... Wait, so... wait, okay. I guess I am actually... I wonder what order these layers are in. Because I want to do this testing... Oh wait, I think I see the issue here. So what we want to do, if I actually am hitting one of these polygons, I want to... Yeah, in that case I should stop, right? Because I don't need to test. I don't need to test any more layers. Right. I don't want to test any more layers. So if after I do this check, I guess, I just check this again, right? So if we did intersect this polygon, we should just break. That might be fine. Yes. Okay. So that might feel a bit better to like work with now. Let's hide this collider debug drawing now. Right. I think that makes sense. It's a bit weird still that you, because if I really wanted to edit these triangles, these vertices, right? I have to hide these layers somehow. Right. Like if I want to grab this, I have to be really okay. Segmentation fault. That's not good. Again. Wait. Is it like when if I okay, okay. Okay. Let's debug that. So when I click my mouse to try to subdivide without actually having an edge hovered, it just crashes. So let's try to do that. Crash. And let's see what the state is. So where am I actually crashing? In the editor at line 125. Okay, I guess. I mean, okay, this is pretty obvious, right? So I just have to check if we actually have a polygon that is closest, I guess, because this is just null. Right, like that. That should fix that. Yeah, that crash is fixed. Yeah, okay, so it's really hard to edit. So I mean, maybe so what would improve this? I think I basically want to hide the layers that are in front, right? That's basically it. And doing that actually on the rendering side is gonna require some changes, actually. Well, I guess that also depends on how I do it, right? Okay. Let me think. I probably want to draw them kind of semi-transparent, I think. And not hide them completely. But that's like also... that's also hard to say, right? So I think the big problem is that this whole world is just a single draw call. Right, so the place where I could do this, I guess, culling, right, or hiding of layers is basically in the world here. So every frame I generate these triangles to render, right? For the GPU, I do that here, fill primitive data. And I pass in the polygon of each layer into this function. And this just outputs the triangles. So I think a very simple way of doing this, I guess masking, is to I could just make it so that the world has some kind of layer mask, right? Of layers that should be visible. So something like a uint 32. Yeah, that's gonna be enough, I think. So 32 layers support, right? So we'll have something like a layer mask. And for now, that's just gonna be all ones, right? All layers visible. And we just check this. If the layer mask, so how do we do this? We do this like that. We want to check the bit. We want to check this bit. This bit. Right. Oops. So that's it. Right. So now if I restart the game, it should look identical. Yes. Yes. Right. So let's try to hide some of the layers. So we're going from least significant bit. Let's actually... let's... 1, 2, 3, 4, 5, 6, 7, 8. 16, 24, 32. Right. That's gonna be easier for debugging. So let's say we want to hide the first layer, which is the frontmost. Yeah, that's gone now. I mean, I guess that's good enough, right? That's probably good enough. So now, I guess the editor would just have to supply this mask somehow, depending on some value. And I wonder how I want to specify that value. Probably by scrolling the mouse, maybe, or maybe page up and page down. Maybe let's use the scroll wheel. It's not terribly important. So I guess first let's just move this layer mask into the world. And we could call this maybe visible layer mask. Yeah, that makes sense. So in the world we will have this, let's put it here. So we have the visible layer mask. And I guess to start, when we create the world, they should all be visible. Right. Like that. And we just need some API then to set visible layers. And I will just supply this mask directly. And this is just gonna be a setter, right? Yeah. So we just set this visible layer mask to this mask. That's it. And now I can potentially see some problems, like if we switch... Okay, so let's try to just implement this first, I guess. So in the editor, we want to have some variable, some layer index to basically start rendering at. I think that's what I want. I think that's what I want, and we can move this forward and back, right? So we will have some what should I call that? Let's call that first visible layer. Yeah, the first visible layer, and that's gonna be initialized to 0, and that's fine. That's gonna mean that 0 is the first visible one, which means all layers are visible. Right, and how do I actually want to modify this? I think it makes sense. Let's see. So somewhere I listen for key presses. Yeah, key down, key control. So insert mode. Let's use that right now. So I want to hold control and scroll with the mouse to change this value. I think that makes sense. And this might be a bad name for this, right? Because this variable now means I'm holding control, which is a bit unintuitive, but let's try that. So if we are in insert mode, holding control, we do this. Otherwise I have some zooming, which the zooming isn't actually working now, but let's keep that code. So if I'm holding control and scrolling, I want to... Okay, I'm not sure what this delta... If it's always +1 or -1. I think it's... Well, wait, first visible... To actually make this a bit easier, I'm gonna make this a signed integer. Who cares? Right, so we just want to first visible layer. We basically just add the scroll delta, and then if we are out of bounds, like if it's less than 0, we just clamp it to 0. And we probably want to clamp it the other way as well. So we have some kind of max parallax layers. It's like parallax layer count, right? So we also want to clamp it to that, so that the last layer is always visible. Right. And now, I guess we could call this API function here. Yeah, let's try that. So we have this, like, what was it called? What was it called? Set visible layers. I mean, okay, now let's do that actually in the updating function. Well, render. Okay, so every... Okay, does the editor not have an update function? Apparently not. Okay, so I'm doing all of this editing logic in the render function, but I guess that's fine. So in here, yeah, I want to call this. Wait, what? I called it editor. Set visible layers. That is the wrong word. Okay, and the editor has a reference to the world, right? Yeah, yep. So we want to calculate this mask depending on how many layers we have, or which layer is the first visible one. So how to do that? I guess we'll have something like the mask, and let's initialize it to all visible, right? And then, depending on this editor, the first visible layer, we want to clear some bits from this. So how would we do that? I think the way is to I think it's this. I think this is it. So we want to take the inverse of this, right? I think that's that. Let's try. So that's working. Which is good. The problem now, I guess, is that we are still intersecting these polygons. And that should be a pretty easy fix, actually. Yeah, I think that should be easy, at least for now, because there's a single polygon per layer, right? And that's just like implicitly known, right? So I guess instead of starting at 0, we just start at the first visible layer. That should be it, I think. Yeah. Alright. So now I can oh. Okay, it feels... I probably have to change this logic a bit. Because like... intuitively, I want to be able to like pick these vertices even though I'm not intersecting this polygon directly, right? If I want to be able to grab it with some radius, so I probably want to change the logic somehow a bit. Yeah, it feels a bit wonky. Right, but now this is good. That I can edit these layers independently. Right. I mean, one potential issue, well, one real issue, I mean, if I hide these layers and go back to the game, it's not reset. And I mean, for now, I can just, because like the editor doesn't really know when it stops editing, right? So I think the simplest way would to be to just reset this this flag. So we have the game render, and in here let's just set this mask to all visible again. And I really wonder why my game is taking so long to shut down. Right, so if I am in edit mode and I hide these layers, I go back, and that's working. Okay, oh, and the state is preserved, right? Right. I think maybe that's good, actually. That feels like it could be good, okay. So, oh god. Slow. I really wanted to fix the zoom, the camera zooming. I feel like I really wonder how many vertices we are pushing, or how many triangles we are pushing right now. Let's check render doc. Crash? It crashed? What? Bad drawable. Wait. Which? I should print out which device we actually select. Because maybe it's picking the wrong one in render doc. Oh. Okay, dude. Like, my GPU is like dying when I close the game normally. I have to Control C it. I forget all the time. Okay, but oh. So what's the issue here? The only thing that changed, like, I did put another GPU into my PC. So let's try to print out which device we select, and how is that determined right now? We have the selected device. All right, and I guess that's, we can just call all of this let's see. Yeah, we can just call this again. So how do I actually get the name? How do I get the name? I like print it here. Yeah, here. So it's in the physical device properties. Okay. And select physical device. Okay, so after we have it selected, we call this get device properties again. So let's just print out selected device. Where, okay, so it does Ooh, it does select the AMD card, which I don't know why it's not working, but I had this issue before. So yeah, what just happens is that I think the swap chain. Okay, so I mean this is pretty bad. There are some validation errors about the swap chain. But wait. So if I run it myself, which device gets selected? Then we select the NVIDIA device. Okay, because that's the first one, but what? Oh my god. So RenderDoc somehow switches up the order of my devices, right? That's really annoying. That's annoying. So how could I fix that? Because like, it's a perfectly valid device. The only issue is that like my Linux distro or whatever setup can't manage it. Like I tried to present with the swap chain, or I think even like getting the next image I think fails. And it just and then just the X then the X client just dies for some reason. Like it's completely, it probably has something to do with that my NVIDIA GPU is the one that's like connected to my monitors and stuff like that. So the AMD GPU probably, I mean, it can't probably render to the whatever, it's something. But I guess the main issue is that I want to be able to choose which device actually gets selected somehow. And I mean, for now I can just do a hack, right? I can do a big hack. So when we have the device name here, we can just check what's the, we can check if this name contains NVIDIA, right? Let's do that. So there's some function for that in C, I think. It's like stir. And this is the haystack, and the needle is gonna be NVIDIA. I think that was the name, right? There was NVIDIA. Okay, so so if the name doesn't contain NVIDIA, we just continue. That should probably fix it. Let's try launching. Yeah, okay, so we get the right device now, that's good. Perfect. And okay, wrong button. So I want to check how many triangles we are actually pushing, because we definitely don't need the same density of this grass, for example, in the distance. I can probably reduce that, but let's see how much we're actually rendering. So 50,000 indices. That's not too bad. Not too bad. Oh, this buffer actually looks This looks... This color looks nicer. I guess my tone mapping is absolute garbage. Yeah. Wow, that's unfortunate right there. I mean, I'm not surprised. My tone mapping, and like maybe I don't even need to render in HDR, right? I probably don't. Why am I even? So I guess all of these values are already... They should be normalized. This isn't actually storing HDR colors, I think. So these white ones, for example, yeah, those are completely white. So, okay, I can just change my tone mapper, right? To... Okay, so I actually removed this. Okay, I don't do this anymore. But why does it look so different? Is it because it's sRGB? It's sRGB. Wait, hold on. So how do I actually determine that? I mean, it's queried somehow, right? Surface format candidates. So I have a list somewhere, and those for sRGB. Maybe they should. Well, let's. Let's print all of the supported surface formats. That could be nice to know. What the hell is this? What is this logic? Shouldn't this be like that? Yeah, that makes more sense. Alright, so... So I want some way to just... Okay, God, okay, okay. So we have the VK format, and I want to print this enum. I want to print this big enum. And okay, that's not too difficult, right? I just have to take all of these, and create some kind of const get format name. Format. Yeah, let's do that. And we have all of this stuff. And luckily we have multi-cursor editing. So like that, right? We want some big switch statement. Like so. That should work, right? Okay, so what's the problem? I guess I also want to, I mean, in the default case, let's just do that, or return it, obviously. Why is everything red? Why? Did I mess something up? Expected a semicolon. Too few arguments. That's not true though. That's not true. Okay, I think IntelliSense is just cooked. Or let's add this print. Surface. Let's say like I guess supported surface formats. Before this and printf. Just add a tab and then put the string there. So we have something like Vulkan get format name, I think I called it, right? And okay, I probably messed something up. Okay, no, okay, it's building. So IntelliSense is just okay, good. Fixed. Where did... Okay, so let's see what this prints. Well, okay, this is the render doc instance. Can I just terminate this from here? No. Right. Okay, so I mean, I guess I should maybe look into. Okay, I forgot to add a new line. All right. So for the wait, I print the name after this, really? Yeah. So let's actually, we have the device properties here. Let's just, first we do is print the device name. It makes more sense. Right, so for the NVIDIA device, okay, these are the only ones. Okay, so, okay, we do support UNorm. I think maybe we actually want, I think we want UNorm. Maybe. Or do we? Or do we? I guess let's try that. So that should be easy. Surface format candidates. And is this still the sRGB color space? I should print that as well. So let's take all of these. Vulkan get, what was that? Color space, right? Color space name. Oi, color, no. VK color space, KHR. Unknown, yeah, unknown. So, yeah, along with the surface format, we'll also print the color space, surface format, color space. And IntelliSense does not understand my function again. Because I think it's fine, yeah. Okay, so that's... I mean, it's hard to know what is correct, right? But at least now, I guess if I start my... If I start this again in the render dock, let's take a capture. And let's crash my GPU again, almost. So when we're actually drawing this stuff into my HDR color target, right? It looks like this. And like I am so bad with color stuff. Like sRGB and stuff like that. Like, but this is what we're seeing, right? And now when doing the compositing, yeah, this looks identical, right? I feel like that's better. I feel like that's how it should be, right? But it's hard to tell if... I guess I could... yeah, I guess I could actually... let's go into some kind of like hex color picker, right? No. Yeah, okay, this looks fine. Wait, what was I gonna do? Right. So I guess we can just compare this hex. So we have some fill primitive data. And here we have this color hard-coded. Right, this is the color of the ground, I think. This is the brown. Or is it? Yes. So red 20, green 10. Because it's also reversed, so this is not like the exact CSS hex color, but I guess we can enter these somewhere, I hope. So the hex will, well, or not. Is there any good color picker out there? Okay, so I can edit the hex, which will be 20, 10, 0. That's very dark, but that's the same color. Okay, so I guess all of my colors were just messed up before. Yeah. They were messed up. Because I messed up sRGB and stuff. So, how does this look if I add back my tone mapping curve? I wonder. I can keep this running and start a new instance. Oops, documents, make and game. Okay, it's like colors are a bit darker and like, yeah, that looks like shite. So let's not do that. Yeah. Okay, so now this is actually what I'm saying is like the true color right now, the real color. Okay, that's very. It looks more vibrant, right? But everything looked a lot brighter before. Yeah. So maybe I want to increase the or increase the brightness of this color a bit, right? So where is this on the? I guess I can try. Let's do something like this maybe. So that's this hex code. And we have to reverse that. So it's gonna be 51 2C 0. Wait, is that's not the. Okay, it is. It is, but okay, that looks way too. I guess it's hard to tell, right? It looks too red and like too bright, but like. Let's try something like that instead. So that's 2F22. Okay. Looks a bit green. Oh well. And I want to change this footstep color now as well. So where is that? Here. Right. So I guess now what? I just want to edit my world now and see how nice looking I can get it with these parallax layers. And something I really want that's missing right now is I want some kind of different materials, I think. Or at least, like, I don't want... Like, this grass is looking a bit... It's really repetitive, right? These flowers and stuff. And maybe I can try to add more flowers, like different types. But it still feels pretty... It feels too... how to say it? I mean, yeah, it just looks the same, like repetitive and boring. Repetitive and boring. But I think this background looks pretty cool, I mean, in general, right? And I need some way of... zooming with this editor camera. Zooming in and out. And maybe I can try to do that quickly. That should be pretty easy. So I have some zooming when I scroll the mouse. But this just changes the camera height. And the camera height isn't even used anymore. Yeah, it's not used. It's not used. So I guess what I want instead is just some offset in the Z direction. Right. So let's say that I have some kind of zoom. Yeah, let's say that. That's good. And let's just add that. Yeah, let's add it to the camera instead of the editor. So the camera has some zoom. And so now when scrolling, instead of setting the camera height, I just set the camera zoom. And let's just try. So zooming, let's try to change this to some fixed value, right? Like that. That works. It's a bit too little. Oh, and I can zoom closer. Maybe that's nice, actually. Not sure. I mean, it feels a bit... And wait. I mean, zooming, I can actually just change the FOV as well, right? But that's gonna have a different effect, right? I guess. Yeah, it will. So, and not sure I like the actual fog changing. I kind of want that fixed. So the fog should somehow be... It should be dependent on the world space position of the vertex. So right now I just use... Yeah, I just use the... I use the depth buffer. Depth. So instead, yeah, and I should increase the far plane. So that's a constant also, right? That could be different. Let's increase that, because that's gonna be increased for now as well, which is not necessary, I think. Alright, so this camera movement is still a bit like it should be somewhat proportional to the mouse, right? Like it's so slow right now compared to my mouse. And the opposite if I zoom in, like it's faster than my mouse, right? So I have to figure that out, how to get some nice movement. Because it's way too slow if I zoom out. It should be scaled up somehow. And yeah, so this fog. I mean, this the like depth is like it's all over the place right now. Like the depth of these in the back are negative, right, instead of positive, which is a bit counterintuitive. And I don't really have like a good range for them either. Like I don't know what the max depth is. But let's try to do something like I want to output the vertex depth into the fragment shader, so I can work with that. So VS output is gonna output, let's say depth. And that's gonna be the Z component of the vertex position. Right, and now I can use this depth to and I don't need the depth buffer depth anymore. Okay, that's working a bit much maybe. Let's scale that down. Yeah, I think that kind of looks fine, and now it's also consistent, right, when I zoom out. Because it's not based on the depth from the camera anymore. I think that's nice. So yeah, I don't know. I probably don't want to be able to zoom in like this actually. But I'm not really sure. Like okay, so let me try one thing actually. So instead of actually moving the camera back, we can just increase the FOV And increasing the FOV should make it look like we moved back, right? And decreasing the field of view will make everything zoomed in, but it won't have the problem of like actually moving through these polygons. So let's try that. So we have the FOV here, which is specified in degrees, and I think it's actually the yeah, it's the whole, it's the full FOV, the vertical FOV. Alright, so let's just try to add this zoom and see what happens. I mean, that's a different kind of effect, right? I'm not sure this is what I want when I zoom. I mean, maybe when I don't know, maybe when zooming in actually, because now when I zoom in, maybe, okay, so if we do like camera zoom and we like want to clamp this, so we have something like a zoom offset. Let's make that, and if it's negative, we clamp it. So that's gonna be this. So now I can zoom, but I can't zoom in farther than this. And why is this different actually? Oh wait, I guess I have this like camera offset, right? Okay. That should be the same as the game. Okay. Yeah, that's the same distance. And I can't zoom in farther than this. I can only zoom out. Makes sense. FOV, let's call it FOV offset, I guess. And the difference here, I guess, would be yeah, we want to decrease the FOV when we zoom in. So if the zoom offset is larger than 0, that's the difference here. FOV offset, and for the FOV, that's gonna be negative now, right? So adding that makes sense. I mean, this feels a bit strange, but maybe it works, maybe it works. I want to scale this up a bit. Like you can definitely feel maybe that works. I mean, hard to tell. Oh, I can invert the camera apparently. I guess that's when yeah, the FOV like flips around, right? And turns everything upside down. The zooming, it should be kinda exponential, I feel like. So we have the zoom offset. Well, I think the exponential is a bit much, but we can do something like, I think there's an F, like pow F? Yeah. We can take the offset to the power of maybe 1.5. That's nice. How am I getting Z fighting? Really? I have C fighting. Really? But that feels a bit ridiculous. Alright, so something else I want to do is to add more layers. So right now we have 4 parallax layers. And I want more. Maybe 8, maybe 16. I don't know how many we need actually. But let's try to do that. So I guess the main problem with this actually is that we can save the world, right, and load the world. And right now the save file, it has 4 layers. And we want, let's say we want 8 layers. So like there's no data to load for those 4 new layers, right? So what should those contain? And I think it's actually fine, probably, if we just increase that value, because we already, when we create the world, we go through every layer and we create this dummy polygon, right? Create a dummy polygon. And we can make this a bit simpler actually. We can just make it like a cube. Yeah, let's make it a cube. That's like 10 units in size, maybe. And the winding order should be clockwise. That's like that, and then minus. I think that's it. And we're not gonna see anything right now, so I forgot I can't close my game normally. So we have this world.bin, which actually stores the world save, like world data. So let's just rename this to like world.bin backup. And now when we start the game, there is no right, I don't want this. Okay, I forgot. So the player spawns at like height 0, and now the player spawned like inside of this polygon, and that's just not good. Okay, but now we have this dummy polygons for each layer, right? That's good. So now if I just increase this layer count, and maybe 16 is, that feels like a bit much actually, but maybe that's needed for like oh Jesus. Jesus, what's up here? What the fuck? Are we like out of space? Are we out of space in like the vertex buffer or something? Let's increase this then and see if that fixes it. Okay, apparently not. Oh. Oh, wait. I might know the issue. Maybe? So, let's see how many vertices we actually spawn here. So when we fill this primitive data, yeah, we can just print this vertex count. Yeah, we have 70,000. And I'm using 16-bit indices, which means that the maximum value that the index can reference, like the maximum vertex, is 65,000 something. I don't know it's 0FFFF, right? So I will just I will increase that. So I will make we will just use 32-bit indices instead of 16-bit. Sure. So maybe I should have type deft that, but we'll have this like fill primitive data. Right, the primitive context probably has it. Yeah, we have these indices, and we have to make this 32-bit now. And that should be right. Okay, so we have to change this as well. But this size is fixed. That should be it, I think. That's not it, because we also have to, in the scene where we actually draw this, we also have to set this this index size. Right, so uint 16 instead of uint 16, we set uint 32. And that's working. Like 16 feels like a lot. But maybe I can. Okay, sure. I guess what I really need, because I'm still restricted to having a single polygon per layer, which is just not good either, right? I want to be able to add polygons and remove polygons, like, yeah. We need multiple polygons per layer. I will fix that at some point. But alright, so now we have 16 layers. And that's working. So we can move back our world save file. And now see what happens when we try to load that. And we put an assert here before. see, in world deserialize, that the save file should have the same number of layers that our game is expecting right now. And I think that's really unnecessary. What we can do instead is just load how many layers this save file has, and just load those, and the rest of the layers will have this default initialized polygon that we saw before, this cube. So I think we should still assert that the polygon count in the file is not greater than the layers that we have support for. So if I decide in the future to decrease these numbers, that should still fail, because then I will do some other stuff, maybe. So, okay, now when we start this game, we have these layers here, so that's working, right? And yeah, I mean 16 feels like a lot, and like I wonder if this should probably be further back even. I should increase the spacing a bit, I feel like, because this really shouldn't be the furthest back layer. And this is so much to edit now, Jesus Christ, 16 layers. 16 layers. Oops. Like, Jesus. And now it's really like the vertex count, I think, or the triangle count is getting somewhat out of hand right now. Maybe not for the GPU, but like I'm running this triangulation function now for every single polygon, every frame. So I am definitely feeling the effects of this. I need some kind of profiling tool, because it is pretty laggy actually. But it shouldn't. Well, I'm printing, so we have about 120,000 vertices, like 54 triangles, 54,000 triangles. That's nothing for a GPU, right? So there's something. We're most likely CPU bound here, most likely. And yeah, I don't have any profiling tools, and I don't want a sampling profiler, right? I want to be able to put in like zones myself to measure, right? I know that there are some profilers, like drop-in profilers I could use. A really good one is the Tracy profiler. But I do wonder if... I think last time I checked... well, it's ImGUI, right? It should have Linux support. It at least supports Linux as like a client. That's for sure. But the server, I'm not sure. He must have fixed that, right? And it's simple to integrate as well, and he does have, yeah, he has C bindings, so that's fine. I guess let's get this. So he has the C bindings somewhere. In public? Maybe? I know this is a Tracy C, right? Yeah, Tracy C. But like, how does this... Don't I need to specify the start and the end? Because like... How does... Maybe he has some examples? Or some tests, right? I hope. Wait, what's the Tracy C? Is that something different? Is this not the C bindings? Or what? Maybe that's in the documentation. C bind Tracy C. Using the C API. Okay, wait. Tracy C API exposes functions with the --Tracy prefix that you may use to write bindings to other programming languages. Well, I'm gonna use C, right? So I guess I just call these directly. Okay. Most of the functions are available are a counterpart to macros described in section 3.13. However, some functions do not have macro equivalents and are dedicated expressly for binding implementation purposes. I mean, I should just be able to call these, right? Let's see how these are used in some bindings. Wrong project. Wasn't there... He mentions like Rust and SIG bindings, right? Oh, and C#. Right, so these are separate projects, right? I mean, unfortunately, I don't know Rust. Let's see how they did it anyway. So somewhere in here they, oops, my clipboard. Right, so somewhere they have to be calling this one in this binding layer. Oh my god. Like, I'm not really... Shouldn't there just be... Oops. So what did this actually do? So we allocate some source location. And what does that mean? Here line is the number in the source file, and function is the name of a function in which the zone is created. Right. So okay. But what about the actual measurement, right? So the Python bindings are in this project, apparently, right? Here, Python. Scoped zone. So how is this implemented? There's a scoped zone class, and does that? I guess that does something in the destructor, right? Because all it's doing is deleting it. Enter and exit. Okay, so this scoped zone has some destructor logic, I'm assuming. So in the destructor, right? Yeah. So okay. So this scoped zone is like the... Okay. Well, in that case, I can just create an easy C wrapper, right? Well, it needs the source location data. And how was that even... How was that retrieved here? So, well, let's see, Tracy .h, yeah, HPP, right? Isn't there like a begin? Yeah, okay, there's no begin. There's only like the scoped zones, right? There's only a scoped one. I mean, I could probably... Okay, let's just try to... Let's try just adding this at least, so that we can get the profiler to compile. Let's try to do that first. And that should be very simple. Let's see. Where is this simple? I don't want CMake like there was somewhere it just told me to copy some files. Was that in the Git? No. It's like Tracy client? Okay, here. Quick start guide. Add a Tracy repository to your project directory. Okay, sure. I will add Tracy as a... I will add it as a sub repository, right? How to do that? Submodule, I guess, submodule. Well, first, I should probably commit what I did. And let's save that world.
I told y'all niggas to close my motherfucking door. Nigga, close the door. Nigga, think that motherfucker. Yeah.
Fix editor vertex dragging and improve colors and fog, something like that. Sub modules. Git submodule add. Should this just be... Should it be the HTTP CPP. Does it matter? Well, I should probably be the... Oops, did I think it's the README updates, right? Yeah, I changed to README on GitHub. Okay. All right, so adding a submodule for Tracy. So the git submodule add Tracy. By default, submodules will add the sub-project into a directory named the same as the repository. Makes sense. Yeah, so we have Tracy, and Tracy, yeah, okay, all the files are here. That's good. Git modules. Git modules. How does that look? Okay, makes sense. Git diff. Right. Add the Tracy sub module. So that's the first step, right? Good. So now how should we actually use Tracy? Well, let's just continue with this integration. Add Tracy client CPP as a source file. Okay, so that's the only... Okay, that's very good. Very good. Okay, so in the makefile, I think for now, let me just hardcode this. So we want to output the compiled, let's call it Tracy, or Tracy client object, and that's going to depend on, that's going to be in Tracy, right? In the submodule, so we have Tracy. Is the Tracy client here? Oh, in there. Right, so with Tracy, public, Tracy client, CPP. And that one, it should be fine to just kind of mix and match. So yeah, we don't really want the same flags here, right? And that's fine, right? probably. So I guess all we want here is to specify the output and the input files. Like that. And for the object files, we have... Yeah, we have all of the object files here, and we can just add this, right? Just add the Tracy client object by hand. So now when I build, it did compile the Tracy client to an object file, but what the hell is this about? Why did my main disappear? Undefined reference to main. What? And Tracy is not enabled, so my assumption is that like this object file is probably very empty, right? What's the flag? T, I think. Wait. It's not here. What? Tracy. Yeah, the Tracy client isn't here. What? But I saw it compile. Did I not? JGCC. Okay, so that's... Wait. Oh shit, oh shit. I have to specify the C. So it should only compile it, right? Okay, so that was what was actually failing. Okay, makes a lot of sense. Makes a lot of sense. So now I have Tracy linked in here. And I guess so it's completely disabled now. Completely disabled, so there's basically nothing here, right? Okay. But it's linked in properly. So if I now enable this Tracy define Tracy enable. So I should probably make some kind of let's call that defines. Yeah, sure. You can do like this, right? Can I do that as an empty string? Oh well, I guess I do want this one, right? Anyway, so let's make that the first one, and I could define this out if I want to later. And it shouldn't really matter here, right? Because we're only linking, right? So the defines don't matter here. But right, so we enabled Tracy. So if we do make, we have to rebuild the entire project, right? To have this flag. Yeah. So that still builds. It still builds. So now, I mean, there is allegedly. Well, there is C binding. There are C functions to help create bindings, right? Question is if I should use those like directly, right? So I'm thinking I should make my own kind of helper functions anyway. So let's call that profiler. Dot, oh, not C, dot H. So I want something like a let's call this profile begin. Yeah, sure. And we have some name here. And end. So the way I want to use this is, let's say, in the main, for example. And this is really I mean, C++ is very nice for this because you can just have a scope, right? But you have to be pretty careful now, like that you actually close the profiling zone. Because like in here, I wanted to have one zone for the whole tick, right? But I really can't do that because there are so many conditions where I just let's see. Okay, shut down, that's fine. Right here, for example, if the frame isn't ready, I just continue. So I would have to like close the zone here myself, which is really annoying. So I will just not do that. I mean, I could put all of this into separate functions, right? And then it would be easier. But yeah, let's... Here it's easy, right? Because there's no control flow here. So we can do that. We'll have like a profile begin. And let's call that tick. Maybe yeah. And have the profile end. And this is okay. This is the only place where C++ is good, right? Where it would have been better. Because now I have to match every single profiling zone with an end, and like I could forget, right? But we'll see how well this works. We'll see how well it works anyway. But that's pretty annoying. So for a start, I think what I would like to do... I have to find the C binding. Binding? Using the C API to implement bindings. I mean, this is basically what I want to do, right? But I want to implement a binding for C itself, right? And I feel like then maybe I should just be able to use these directly. So where are these? Well, maybe, actually. Well, it feels easier. Let's see how... So we're at Tracy HPP, right? Which is the C++ API. And how does this handle like a scoped zone? How does this do it? Zone named. It creates the source location data, which yeah, that's not gonna be possible. I need to get that some other way, right? With some macro magic. But it creates this scoped zone. Okay, so I think that's what I basically want to do, right? And maybe the source location isn't necessary. But I don't know. Let's try this. I guess first maybe how do I actually build the profiler? Hello, quick start. I could guide. Quick start guide. Yeah, so I'm here. Frame mark. Right. This one should be pretty easy, I guess. So, okay, let's skip the zones first, actually. So we want something like a profile frame mark. Yeah, let's copy paste his names. And I guess how do you check for C++? Is it like C++, right? Something like that, right? Maybe if def. I have to check that. It is C++. Yeah. Because this should all be C functions. You can do that after. So, right. Well, no, we'll do it like this. Extern C, right? And we want the whole scope. So we're gonna have some functions. Something like frame mark. And this should be pretty simple. And let's say that this function just calls this, right? So we should be able to see something, even though we don't have zones. with this framework if it works in the Tracy profiler server. And now the implementation of this should actually be in C++. All right. And I guess something I want to do first is add Tracy as an include directory. And which folder should that be? That should be Tracy public should I add this? Let's see what they say in the documentation. Add Tracy as an include file. Okay, so I will just include this public directory. So that's going to be Tracy/public yeah, that's it, right? Tracy public, and then we will include the Tracy/Tracy HPP. Now, I guess the problem here is this is only compiling the C files. And I'm not sure how to like okay, this is a bit I'll just copy paste this. I will copy paste that and we don't need Vulkan. Like this is really specific, and I guess I can be even more specific, right? So that's a profiler CPP, right? That's the only CPP file we want to compile. I think all of these flags should be basically the same. Yeah, and for the C files we don't want Tracy, actually, the include files. That looks fine. So now we only have to so we're figuring out the C objects from the C files. I guess all of this how would I append to this list? Is it just plus? Let's see what happens. So I have this debug. So if we make a debug, what? Okay, let's not do this. That apparently what the fuck is happening? I'm compiling. Oh. Okay. Let's do that. Implicit declaration. Right, I need to include the profiler H. Alright, so now in our main loop, I think it's best to do this at the end, basically. So after I've submitted after I submitted the command list to the GPU, yeah, I'll just put it here. So we have this profile frame mark. I want to call this profiler frame mark. Right, so this builds, and this is unimplemented, which is expected. So let's implement that. And I guess we still need like to do extern C, right? I'm pretty sure. So now we have that, and we should be able to include Tracy and Tracy HPP. And here we have the frame mark. Yeah. So that's gonna be the implementation of this. And I guess it should actually be a void, right? Still undefined reference, and I guess that's because... Yeah, right. That's because we need to add this object manually, right? This obj profiler.o. I should fix that later. Undefined reference. Maybe... Does the order of this actually matter? Okay, so all of this send frame mark, that's undefined reference. Strange. Using GCC should be fine, right? I don't have to like use a G++, right? Maybe I do. I don't know. I don't know. Mixing C and C++. Right. I guess. I mean, okay, let's try. So if I use G++. For the linking stage? No, I mean... Yeah, I mean GCC, surely GCC can... Because, I mean, I built the Tracy client, which has all of these symbols, right? That's in the Tracy client object. Well, they should be there. I guess if I can check that. So if I obj dump the Tracy client, okay, I mean it's not as it does actually seem like there isn't the Tracy client. Yeah, it's way too small, right? It's way too small. So, what's up with that? What's up with that? I define Tracy enable. Oh, Tracy client. Oh. I didn't. Okay, that's the problem. That is the problem, surely. Yeah, now it's really compiling. So is that actually failing? No, okay, so the Tracy client is... It succeeded. Do I have to switch these? Yeah, that doesn't matter, right? Undefined reference to stud chrono. Do I have to do the linking with G++? Okay, I do. Okay, this is really scary, and let's see if the game still works. Yeah, the game still works. So that's good. Very good. And it's so it should actually be calling this frame mark function right now. The real one. The send frame mark. Right. But I don't think anything is actually happening. So I guess I should, to compile this C++ file, I guess I should use G++ as well, just to be safe, right? Right. Okay, so Tracy should be enabled. How can I compile the server? Should I use CMake? Probably, right? Wait, is that it? Wait. Okay, so the server is just... Okay, does he have a guide for that as well? Compile and run both your application and the profiler server. Okay, so how do I build the server? Oh, embedding the server. How do I build the server? Server? Building the server. Tracy uses the CMake build system. Unlike in most other programs, the root level CMake lists file is only used to provide the client integration. The build definition files used to create profiler executables are stored in directories specific to each utility. Really? So I'm guessing that the server is the actual. Oh, maybe not. So right. Okay, so the profiler is the actual. Okay, makes sense. So the profiler is the server. The easiest way to get going is to build the data analyzer, available in the profiler directory. Then you can connect to localhost or remote clients and view the collected data right away. All right. So I wonder where I should put that. I mean, it would be nice to. I will put it in my home directory. Sure, so it's something like. So I'll make a Tracy folder and the profiler would be in here. Right. Because I think if I do create a directory in here, like that's gonna show up in Git and stuff. And like, yeah. Let's try this. So we'll do cmake on the. We want to do it in my submodule. So the profiler. It's like that, right? Do I specify the cmake lists? I think I just specify the folder. Right. And the current directory will contain all of the results. A required package was not found. Do I really need Wayland? Please. Okay, so use Wayland. I guess that's default on, right? Or, so what's missing? Wayland protocols. Wayland protocols. Yeah, that's only checked for if Wayland is active. So this use Wayland. How do I set this stuff to false? Right? Is that just an environment? I mean, it should be. Like what says that this should be okay? And not legacy. Has legacy equals 1. Like, do I just do that like that? No, it's still looking for Wayland protocols. So how do I actually set like a? Okay, I can just use the cmake GUI, right? Do I have that? No. I will just install it. Cmake. Oh, it's the cute GUI. I guess. I at least I know how to use that shit. You can like see all of the variables right in the window. With OpenCMake GUI. Where to build binaries, that's gonna be in Tracy. And yes, configure. What do you mean does not exist? Wait, is there any files here? Okay, let's reset. Okay, home user, it doesn't understand that, okay. And now configure. Specify the general. What the fuck is Green Hills Multi? What the I mean, Unix makefiles should be fine, right? I don't know what Green Hills Multi is. Finish. Okay, and do we get the same error? Yes, we need Wayland protocols. So, okay, it's not here either. So is that an environment variable, right? So it checked. It's probably hitting this, right? And not legacy. And I tried setting this legacy. Pass legacy equals 1 parameter. So is this just an environment variable, right? Or is it an entry here, right? Like, let's try the environment first. Oops. So we want to add legacy, and that should be 1, right? Okay. And now what? It's still looking for Wayland protocols. So is it like a bool here, or what? So legacy, set that to true. Okay. Configure. No. To build a profiler GUI with Wayland. Yeah, I don't want to do that. And it's only checking for this Wayland protocols if use Wayland is active. And I already checked this, like, use Wayland is set if we are on Linux, and it's not legacy. Okay, so what if imagine if I just set this to off, will that work? Yes. Yes. Okay, that's a proper fix right there. So now generate. Oh my god. Okay, so these are warnings. Why are the warnings red? Like, looks like errors, right? So now we have a make file. Yes. So now make should just work, right? What's capstone? Capstone is a disassembly library. Okay, nice. Do they not have a website even? I guess it's old or something. I guess that's all you need to know. Like immediately when you get to C++ libraries, like the compiler is like twice as slow, at least, right? Nice language. Come on. are linking. Oh wow, the linker is multi-threaded. Apparently. Impressive. What? It built this library after. Okay, so it's not needed, I guess. Okay, so is this actually gonna work? Oh my god, it's working. Would you like to... achievements? No. Okay, I actually have used this before, so... right, so I guess the client is sending this frame tick thingy, right? So I guess connecting should just work. Yes. It does work, but do I... Yeah, and I get the frame time as well. It just works. Right, so I can pause this. Can I see, like... Yeah, I mean, I don't have any real zones, and I guess you can't really inspect this this frame marker in any useful way, but I can see, I mean, that it's very... Oh. Where did it go? Hello? Oh. It's really uneven, right? But that's really not unexpected, I guess, because I have a fixed tick rate, right? So only some frames are actually ticking the game. Right, so I guess we can try to get some real zones working. And yeah, we'll see how that works. We'll see how that works. So I already added the macros for this, and I placed one at the game tick. So let's also make something like a profiler zone begin. We should probably have the name here at least. We'll just call those like that. So now I saw in Tracy HPP here we can do, and looking at how the Python bindings work, I think what we want to do is just create a zone, but it will be on the heap instead of the stack, and we just delete it. Like, it's gonna be really stupid, and I am going to malloc every one of them. So it's gonna be very slow, but I think it's gonna work anyway. That's how the Python bindings did it. So we have this scoped zone. Yeah, that's a real class. So this measures the time between the constructor of this object and the destructor. And the only problem is that oh wait, okay, we actually have a nice constructor here, because we need some kind of source location to give to this Tracy profiler, which I'm not sure how to get. I mean, you basically have to use some macro magic. There is like some built-in macros that tell you the source file name and the line number of where your macro is. But for now, I will just ignore that, and because Tracy should work anyway. It should still have the time and stuff like that. So, when we begin a zone, right, oh, okay, we only have a single zone right now, so I think we need some kind of stack later. Because if we have zones inside of zones and stuff like that. But for now, I guess... Okay, let's... Yeah, okay, this is gonna be extremely... Let's just have a list of these. So we have some kind of zones. And let's make... And that's Tracy's scoped zone, right? In that namespace. Tracy scoped. I don't have to include that myself, do I? Yeah, no, it's just IntelliSense. IntelliSense doesn't know that I have Tracy in the include directory and stuff. But alright, so that should be 0 initialized, right? Because it's static. So when we begin a zone, we just create a new one of these. Scoped zone. And we check. I want to use this constructor, so let's copy that signature so we know it. Okay, so I'll just enter dummy data right now. So line 0 source is going to be your mom.c. And the source, what's the source SC? Is that the length of the string? Source SC. I think actually he wrote something about this in the... Yeah, source SC are the size of the corresponding string arguments in bytes. So should that include this 0 terminator? That's 9 at least. Source and the function is just something, right? It can be anything. It's just a string, I think. And that's 6. And after the function, we have the zone name, right? So that's actually the name that we sent in here. And let's just call it Sturlen, right? And the color, white, is active. That's just true, probably, right? Right. So this is like extremely silly, right? But it should work. That's all I care about. Like we can probably make this better and like actually pass source information later. Okay, so that builds. So if I now close the game, and I forgot that my GPU doesn't like that. Again. Okay, so now the game is started and we should have a zone now, and nothing crashed yet, so that's a good sign. So if we connect now, I think I saw a zone, maybe. So if I pause and check, yes. Yes, that's working. Okay, that is cool. So now, if we have nested zones, we need some kind of stack, right? We need to keep track of how many zones we currently have in flight. So we'll have something like the zone, let's call it count, whatever. Or zone top, I think that's better. So that's gonna be like that, right? And here we pre-decrement Yes, okay. So now we can have nested zones, that's fine. And let's just... Let's just check that we don't run out of stack space. And I really don't like that IntelliSense doesn't understand this. I think I have count off here in util, yeah. And we need assert. That builds. So we can add some more zones now. So I think the actual. I really wonder what's taking all the time, because it's really not the tick, right? That was like, yeah, 50 microseconds. Not too bad. Not too bad. So we have a lot of more stuff going on in the frame, right? So this is just the tick, single tick, and we have the rendering. That should also be pretty fast, I think. So, but let's put this, so profiler and game render and editor render. And what more we have? We have some updating here. Okay, so this is basically my like per frame update place, right? So we can call that update maybe for all of these. And maybe if this takes long, we can just add more profiler end. I think that's basically everything that's gonna take time. Well, the game render and like we have like the scene. Okay, the scene draw, that might be worth checking. Right, so let's restart and connect. Right, so now we have a bit more information. So if we pause. Right, what's taking all the time? Update. So something in update. 7 milliseconds. 7 whole milliseconds. Okay, so what is actually taking so long? It's not going to be the model loader, because that's not even used right now. I don't have models. Profiler and it might be the world actually. That's my bet, at least. It's probably filling the like, yeah, writing all of the triangles to render. That's probably it. It's impossible that it would be the wind that's doing nothing. Barely. Particle system, maybe. Okay. Okay, so we have some sample. Yeah, it's the world. It is the world. Definitely. That's taking all the time. So I guess we can add some profiling zones in the world to make this a bit more detailed. Wait, profiler, right, .h. So the world update. Let's see. Well, first, actually, am I still connected? Right, so I want to check how slow the editor is also. So if I'm in edit mode, yeah, the world update is still taking up everything. Yeah, right, okay. So it's probably not going to be the triangulation function. That seems pretty cheap. Okay, so it's definitely uploading the triangles, I would say. I guess we can profile each one of these. Profiler, begin, fill primitive data. And we can profile these mem copies, but that should be really fine. Oh, profiler, and it should be fine. Like it's just copying this data. So we'll just call it staging copy, maybe. Alright, so it is this. That might be hard to see, actually. I wonder if it's possible to make all of this GUI bigger. Options. Doesn't seem possible. Doesn't seem possible, but I can at least let's see. I can make the zones not white, maybe, to make them a bit more easy to read. Just make it like a gray. Like that, and I just also realized I can just do an what's it called? A placement new, right? I can do a placement new and a placement delete on this stuff. Well, I guess placement new is the only. Wait, how does placement new? Is there a placement delete? I don't know. I haven't used C++ like that in a long time. So yeah, you do placement new, and if you want to call the destructor, you can't just delete it, right? Or right, I call the destructor. Okay, that makes a lot of sense. Right, so I want to do new on this zone, right? And then I call the what's it called? Scoped zone, right? Call the destructor. I think that should work. Base operand, right, it's not a pointer. Is that? No matching. Okay, do I need like if I take the memory? Is this fine? Okay, whatever. It should be possible, but let's not bother right now. Alright, so let's check how this looks. So we have filled primitive data, and alright, it should be the mem copy is at the end here. But yeah, it's definitely this filling of the triangles that's messing us up. And I mean, I guess really we don't have to do that every frame. I just made that because it would be simple. Instead of, because it's only for this editor, right? If I draw some vertex around, we have to regenerate the whole world. And I could just check that, just have some kind of a dirty flag, right? To check if we actually have to regenerate this data. That's one option. But it's really still slow, like even... It shouldn't be this slow anyway. I just think it's doing too much, maybe. Like, I really have to improve this. Like the spawning of this grass, for example, right? It should be cold and everything. I don't really like that it's a part of the normal geometry. Because like the grass is still there now, right? To the left of me and everywhere. Like even though it's not in view. So I want some culling on it. But I guess it's good to know what's taking up so much time. So that's 7 milliseconds. 7 milliseconds. Just to create these flowers. Do I have some value for... I want to increase the... I feel like I want to increase the distance between these parallax layers. They feel a bit too close. Like this is 16 layers. Like I want the layer in the back to be like way behind. So I think that's right now. I have this function to get the parallax layer depth right here. And this is just hard-coded. Right, and I normalize it, right? So let's instead... let's not do that. And let's have some fixed distance between the layers. Maybe 2 units. It's a bit better. Maybe I can push it a bit more. Now there's a lot of fog on that. This is probably reasonable, right? Maybe 4. And I should decrease the fog amount. That's too much fog. Maybe I can clamp it. Let's see. Okay, it's not completely white now. I guess that's... Would be nice to have some noise texture, maybe some variation in the fog. Right. I think if I, like... I think it has the potential to look pretty good now, actually. Like, if I... It's just... like, cumbersome to edit still a bit. But, like, it can be pretty dynamic, like, with this background and... am I missing some layer? Right. I have to fix this. Like when I'm dragging a vertex, I gotta fix which polygon is highlighted, because I guess sometimes, yeah, it's not inside of the same polygon. Like it's still just picking the closest vertex, which is a bit silly. I guess I can fix that really easily, maybe. Probably. So in the editor, we check here, right? We highlight the closest polygon. Okay, so I guess instead we want to basically highlight the polygon that we're editing right now. So let's do something like we want a polygon to highlight. So we have the highlight polygon. Let's make that null to start, and we want the highlight vertex. Well, do we? Wait, hold up. Okay, so this is... how do I want to... I basically want to check, like, because we have this editor edit polygon, and if we have this one, that means that we are currently dragging around a vertex, right? That's how we keep track of that state. So if we have a edit polygon, maybe I should just... Wait, where do I actually... Okay, right, I have a function to debug draw a polygon. Okay, so let's just check if the edit polygon is not null, which means that we are dragging something. Then we should just highlight that polygon instead. Let's try that first. So, oh no, I forgot to save my world. Oh, goddammit. Okay, so that's fine now. So now when I'm dragging a vertex, it's not doing this normal that's nice. I guess that's it, right? So if I also subdivide this edge, yeah. Okay, that's nice. Like 16 parallax layers, it's literally so much to edit. Like, I think I need to maybe simplify how I edit polygons. I don't know. Like you have to be really subtle also with like, because the contour should mostly follow the foreground, right? You just want these layers to add some kind of depth. Alright, but now I already... I should have committed these Tracy profiler changes before. This is fine, I can just separate that out, I guess. So we will add profiler, add the make file, add main, add well, not world probably, right? World.bin. Well, what did I change in world? Right, I added the profiler zones and this. But let's... Okay, whatever, let's add all of it. Except for this... I did this hack, right? And I did this hack somewhere. Use Wayland, right? So if I just revert this... yeah, that's fine. Okay. So... implement Tracy zones, I guess. Increase parallax layer distance. And I guess that's it, right? That is it. And I have a Git repository now. If you want to check the code. Also, maybe I should link that somewhere in my bio, maybe. I can just send it also. If anyone wants to look, and I should probably update this screenshot actually to make it up to date. That's probably a good idea. I need to get a nice angle. Okay, let's actually let's tidy up the world first before I take a screenshot. I think this looks cool, maybe. Actually, with this like foreground is hiding a lot. I should move this down. Something like that. This looks pretty cozy. Alright. I guess I don't even... I could take the screenshot in edit mode. There's a red dot in there, but that's fine. So it's... yeah, it's that one. Oh. Yeah, okay, so... oh. Well, hello, is GitHub that slow, or what's... like a readme... yeah, it's just referencing this screenshot PNG, right? Does it take some time to update? Surely, like, if I go into the docs and check the screenshot... what? Update screenshot? Well, that's pretty cool actually, that GitHub can diff images. But yeah, it's obviously updated, right? But why... if I go into the docs and check the screenshot, it's the old one. Okay, if I do shift reload, it's the new one. Maybe it just needed some time, I guess. Okay. That screenshot is way better. Especially when I realized I messed up the colors completely. Right. I can remove this debug printing triangle count and index count and vertex count. Alright, and I did see that we have some validation errors from Vulkan. So what's the problem? Rasterization state line width is 4, but the line width state is static. And wide lines feature was not enabled. Wide lines, okay. I will just enable that. I will enable the wide lines feature. That's here, right? Wide lines, wiki true. Okay, one down. That's okay, that was all. Okay. I forgot to enable wide lines in Vulkan. Okay, good. I mean, I like that the driver just doesn't care, right? It works anyway, it just does it anyway. But I guess it's nice to tell the driver that I want wide lines. Okay, that's nice. So that's fixed. What's this running? Render dock, I guess. Enable wide lines. And now what? Is there anything I could do quickly? This sea fighting is very suspicious. Actually, I would not think that the precision is that bad. I mean, it is close to the far plane, but like, it can't be that bad. That's crazy. That's even here. Like, do I have to use reverse depth? Or what? I mean, I am using a U-norm depth buffer, right? But I mean, I don't use that fact now. Wait. So if I just change work the render targets, probably. I have the depth format. And I use the U-norm depth. I guess that's not good. So what about D32 as well? I mean 16 bits, that should be enough. It should be enough. The only issue is, I guess. Yeah, I have to figure it out, because it doesn't need to be the real depth, right? It shouldn't have to be the real depth, so it should be enough with a 16-bit, but as I'm using it right now, apparently it's not. So let's see what happens with the 32-bit depth buffer, and that should be fine, I'm assuming. Yeah, there's no sea fighting anymore. So I guess that's a fix in theory, I guess. Well, in practice as well, but it's not a good fix. Fix C fighting. All right, but I think that's enough for today. Got some progress in though. That's good. That's good. Yeah. And check out the Git repository if you want to check the code. Check what's up. Oh, and also, wait. The Tracy profiler also has Vulkan support, so I really, that's for next stream, probably. They actually have GPU timer support. That would be cool, to check the actual, how long the GPU is taking. I'm assuming it's not a lot, actually. GPU is barely doing anything. Just drawing some triangles. But yeah, getting Tracy was nice. Really nice. Because I had no idea... Oh, I had no clue about how fast or slow things were. Right, so that's very nice to get some idea. Yeah. Oh. My GPU almost died again. But that's it for today. I hope I will see you later. Bye bye.